All right, what is up, everyone? My name is Maurice Diaz. I go by I Grow Soil, IGRO Soil. I'll throw that up there so you can see the handle, logo. And I didn't want to overthink this video. I'm extremely grateful Matt invited me to speak here and share. Not speak, I'm just sharing what I do. So I'm a proud alumni of Matt's Regenerative Soil and Regenerative Soil Microscopy. And I've been doing this for about a year and a half. Before that, I had never put a plant in the ground. I had never seeded anything. I was a contractor by trade, and I spent my life working 70 hours a week. That's about it. I mean, I was disconnected from the world, disconnected from everything, and had no clue as to what was going on. Quick story is that I fell ill. You know, I find that a lot of us are, I call it battle tested. You know, it seems like everyone that does what we do that I meet are, one, extremely grateful to be on this planet, and two, somehow have been through some up and down in life that is just kind of kickstarted us in the direction that we're in. But as I was rehabilitating, you know, it took me years. I was being eaten by a flesh-eating bacteria. I won't get into that story, but it's gonna take me out, you know, and you know, it was a lot of hospital time. It was a lot of downtime, but having to find the positive, right? Because you know, it's all negative, 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 negative. And they send me home with this lunch bag of medications and pills. Again, I won't go deep into that, but the final outcome of this was this obsession that I had. And I could fairly say it's an obsession with soil microscopy, microbes, if I had to boil it all down. So much so that I didn't even care much for the growing anything at the time until I learned that the plant feeds the microbes, and there's this relationship between microbes and plants. What? Right? Couldn't believe it. I started scraping the web. I found Elaine Ingham, which I'm going to summarize my thoughts on her very simply. Why does she not have a Nobel Prize? Just saying. And in these searches, I find Matt, and Matt blew me away. You know, I'm 47 years old at the time, and I'm finding this guy who's enthusiastic and made me say, man, it's not too late, right? This is really happening. Is this really going on? And so I'm going to take you through this journey, but I didn't want to overthink this video. So I've got you out in the field with me, man. That's the best way I can do this. This is who I am. This is what I do. I can't sit there and structure something. My mind doesn't work that way. I'm go, 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 go. So we're better than out here, Gardens in Glass, where I've been able to really fully express myself by following Matt's instructions. Again, a proud alumni of both Regenerative Soil and Regenerative Soil Microscopy. So part of what I learned with Matt is right away, you're going to have to go beat down doors. You're going to have to go meet people. You know, construction world, sure. But with what we do, I didn't know anyone. So as I started this journey, I started testing it. I had to see if it was real. I had to go see this. And as you can see here, I decided I was going to turn sand into soil because Elaine said you could do it. Matt said you can do it. Before I go all in, I had to do it. And these are the results of that. And as I grew into this, oh man, I was stoked. I just think this is the thing. So here's where I'm at, and I met Rick. He's the owner of Gardens in Glass.
Absorb the minerals to make them more readily available for the microbes. So they've been in here about a week. Now this one here has the leachate in it. It had a little piece of fruit in it, and my leftover bag, because I'm doing an experiment of 3 bins over there with you. You recognize that bag, don't you?
Yeah. Ceramics.
Now that's got leachate in it, so I'm trying to use the leachates.
Man, look at that.
I'm using.
Is that your SCD stuff?
No, this is the leachate out.
Oh, wow.
So it's got some fruit. It's got.
Yeah, that yeast is going wild.
But FAA all day.
A little rhyme, dude. That's amazing.
Look at them. We gotta put some more And we're just going to close him up, and then we'll put more in tomorrow, and then we'll top it off with molasses.
So that's not even scratching the surface. I believe that was New Year's Day. And I went over there to just drop in on Rick, and we ended up the entire day composting and Rick just dropping knowledge, man. He's so filled with information, so many microbes. This guy's been farming for over 40 years, and he's just always just giving data, and I'm just absorbing it as much as I can, as fast as I can, and I'm putting it to work. Matt always says, put it to work. Rick's always, Mo, we're not going to know until we find out, and the ability to be able to just do that, extending his property to me and allowing me to do this. Then he's got Daniel there.
Rick, you got a plant addiction? Is that what I heard?
Yeah, that's what the wife says. I have a plant addiction.
You go to like Plant Buyer Anonymous classes
No.
or anything? Or?
I just come back out to the yard.
All right, so what have you learned here? I mean, what can you tell me from the garden? What kind of, like what's been the biggest learning factor, and what do you have for people that are watching at home, like they're like scared to even plant something?
I would say start small. Start small, find something that you like, whether it be native, flowers, edibles. Get a small plant, put it into something a little bit bigger, a pot, maybe stick it in the ground, and give it all the attention you could afford to give it. The more attention you give it, not necessarily feeding or watering, but just visual attention, you'll come to understand the plants.
Love it. So
just grow, and grow obsessively.
Keep it up. Mr. Rick, thank you for your passion for plants,
Pound dirt,
edibles, natives. I mean, nature loves you, man. Thank you. We appreciate you.
Daniel's just a whole nother level. I mean, we're talking about this guy's been growing for 30 years. Now, remember, I've never put a plant in the ground, so I don't know the difference between black and white, honestly. So I'm here just tapping into this matrix of information and able to get hands-on. That's my thing. I got to get hands-on. That's who I've always been from anything I've ever done. So Daniel, student of the Soil Food Web, microscopist, rocks the Infinity LW's I4. We've got a lot in common here. I'm basically, I feel at home there, and we're sitting on just about 2 acres out there. And it's just a constant composting and growing, and be able to just ask someone at this caliber just allows me to grow even that much faster, right? And I've got all of Matt's videos and all of his classes, which you never take it just once. So this lifetime thing that he offered was another big deal for me, because I have to just listen on repeat and just drive this information home. So let's get into the scope. Let's build this phase composting. Phase composting, in a nutshell, to summarize it, I'm taking biology and taking compost and organic matter through all phases of oxygen. So anaerobic, anoxic, suboxic, and oxic. So we're starting completely underwater. As time goes by, it just starts to decompose. These microbes are doing their thing. These electrogenic microbes. Let's talk about these microbes that just tap into each other, transfer electrons, that controlling the redox potential in this system, managing it at a very good pH. The seed pressure. What seed pressure? You're decomposing. So the seeds decompose in there. So the final product is this wonderful, outstanding soil compost that I can then turn my soil and build it. Get this sand that we deal with in Florida, and really get all this beneficial energy is what we're building here, right? It's energy is what I see. It's add more. That's why spirulina, chlorella, all these light-eating microbes, purple non-sulfur bacteria, all I see when I'm inoculating this is adding energy. The potential there for me, I can't even tap into. I'm sure in a couple of years, I'll probably be satisfied with some of the information I've learned. But right now, it's a race, and I don't know what I'm racing, but yeah, you just gotta get your hands dirty, and understand that There's a lot going on in this system. These electrons are moving energy to humic acid, to fulvic acid, to carbon. Get it stored in there. These things are donors, and your secondary metabolites, and horizontal gene transfers, the gene transferring, right? They're just mutating, and it's just so much happening there. And it's all diversity. At the end of the day, it's all diversity. It's getting these just monic acids in there, and these plant hormones that trigger the plant to grow, right? Get them in there, knowing what you're putting in there, understanding your input. Input output is always my thing. My input is going to determine my output. And this is how I go forward when I'm composting. And for me, inputs can come from anywhere. I have local people who bring me inputs, which is amazing, because this came from this lake, and this came from this little. They know that I love the aquaculture, these microbes, these algae. I'm in Florida. If I leave a bucket outside, in 5 days it's growing algae. How lucky am I? So understanding the importance of all these things, and even what I don't understand, the ability to extend this education beyond Matt's course, meeting again people like Rick, Daniel, and everyone else that I'm surrounding myself with is just pushing me at a whole nother level. I'm in an accelerated learning. I'm feeling I'm getting old, and again, I found a passion in life when I was 50, 48. So I feel like I have this race to absorb and learn as much as I can. I'm on a rant here, but with that, let's go. Let's take a look at what this olive barrel looks like, and these Bokashi leachates. You know, we know what they look like. We know what they smell like. Let's take a look at them. Let's go in the scope. All right, so let's get into what this looks like. These fermentations, these anaerobic concoctions, your Bokashi leachate, your olive barrels, they all look pretty much the same. There's not much to look at other than bacteria, but it's still exciting to me. So here we are, 100. This is right out of my olive barrel. I've literally just went out there to harvest this to show it. It's got a bunch of everything in there. A lot of, again, organic matter, weeds, fish, you name it. I try to get it in there. I try to get as much diversity as I can in these fermentations. So we're at 100. I'm going to just skip to 200. You can see all of the organic matter everywhere. And then I'm gonna jump right over to 400. That's where we start seeing the action as far as the bacteria. And a matter of fact, I'm gonna do this. I'm gonna pull my slide all the way. Yeah, I'm all the way above the slide, and as I move into this slide, you start seeing the bacteria. That's right about here. You see it all, and as a matter of fact, I am going to take you to 600. So here we are. I'm all the way above the slide. So I've dropped my stage down, and what I'm doing is I'm making it so that if you would imagine that this is my piece of glass, this is my objective. I'm going to get closer and closer. We're going to go deeper and deeper and deeper into this slide, because there, believe it or not, is depth. 2 pieces of glass, and there's depth here. So this is all this bacteria. You see these rods. I'm at 600. This is as close as I'm going to get. But here I go a little bit deeper. And let's focus even on the background here. That shadowy orangish thing, that's a piece of organic matter that we're eventually going to get to as I go deeper and deeper. So I'm going to go a little bit deeper now. There's the next level of bacteria. Next level of biology. I'm going to go a little deeper. There's another layer. So I can take you through this whole thing until we finally get to that organic matter. We're dialing it in. But this, if you can understand why they say that your KNF and your natural farming fermentations, you dilute them 500 to 1,000, we're looking at a drop of that fermentation out of an olive barrel that I've added all of my leachate to and just ferments plant matter. And here we are. We're finally dialing in to the level of the organic matter, sitting probably towards the bottom of this slide. And at 600, let me see if I can get it better. I mean, there's just so much happening here on this field of view. I'm gonna move around a little bit. So again, like I said, it's a lot of the same here. We can't identify what we're looking at. I can't identify what I'm looking at without sending this to a lab and having some DNA testing done. But I don't care. This stuff's amazing. You know. So again, I don't want to drag this long because I've got a lot to show you and I've got a lot to say. We're out in the field. We're out here at Gardens in Glass, and I want to talk to you guys about something that I've labeled phase composting. I did not come up with this. I'm sure it is very old, but Rick is the one who's put me onto this. Rick has become a mentor to me. Here at Gardens in Glass, if you look at any of my videos, the man's about it, right? And I couldn't be in a better place. And following the protocols, Matt, believe me, Matt's not paying me to say this. I just followed his course, and I followed it diligently because I feel, it's funny when you find a passion in life. All of a sudden, I felt like, man, I need to be around long enough to do this as long as I can and be as healthy as I can doing it, because I left that hospital upside down on 7 different medications, an A1C of 9. I was completely unhealthy, and I was also not connected to my family. My parents lived 10 minutes away, and I had gone weeks without seeing them. Before I know it, I'm in a hospital upside down with no visitors, and the chances are 1 in 5 that you're going to survive. And I was in there for months. Um, but I found soil, which was just mind blowing to me. And when I got out of the hospital, my mission became worms and soil. But again, I'm going to push away from the story. I want to talk to you about phase composting, and I'm going to just cut pieces of this video out. And what I'll do, my email is igrowsoil@outlook.com. Send me an email and I'll send you a link to this video if you want to see the full video of me making this phase composting, because hands down, the biology has been unmatched. I have not seen anything, and I live on the scope with this much life, and I've just got my theories and science that back me. And we're talking anaerobes, and are they the true bad guy? I disagree with that, and a lot of this some freestyling. So let's go with it. I'm going to take you into clips of these videos. I'm going to take you into what that looks like under the scope. I'm going to at least put up my best argument as to why. So without any more delay, let's get into this. These things going here. So basically what phase composting is, we fill these these trash cans. These trash cans are filled with biomass. I'm going to take my time with this video, so it's going to be long. We fill it with biomass. We go after endophytes. We go after native stuff. And I brought chlorella that I've already been adding. I brought effective microbes. I brought purple non-sulfur bacteria. This is mushroom blocks. This is 3 types. This is 3 phases of wood chips. Fresh, somewhat composted, and then a little more deeper composted. I'm going to end up adding some of these Johnson Sues. Samples from all of these Johnson Sues are going to go into each one of these things. So at this stage, this is how I'm going to grow this out. We're about to get some rain. Every foot and a half, I'm going to add biology. I'm going to add microbes. And the more microbes you have in here, the quicker it starts cooking. This is the nutrient mix that we were looking at earlier in the brute cans over there that Daniel's working on. These extra microbes in biology that we have, they're not necessary. I make purple non-sulfur. I make my effective microorganisms. I make a whole bunch of stuff. Spirulina, chlorella. So yeah, I'm gonna add it. If you have pond water, add it. Right over here, potatoes, food scraps. So you start working it in, layering it in, and all your biology is gonna come out of here. I've already posted all this stuff under microscope here. Look at that. Oof, that's fish. That's for sure fish. So you see what I'm saying? Take your biology from your food. If you have all the extra stuff, then why not? Michelle's cutting in grass, Johnson grass, and is that native, Rick? Probably native. It's a nuisance. Good. We want those endophytes. All right, so here's the first sample. I went about almost halfway down the brute can here, but look at it already. And then the ultimate test, just remember, is that if you could take one of the wood chips, even something this small, and just snap it in half with zero resistance. But I mean, look how amazing that looks already. This has only been about a month. So I'm going to take a sample from this, and this is what that looks like. All right, so we're looking at the, I guess the first brute can, the one that doesn't have any holes in it. And it's already got a lot of action. I'm at 200 magnification, and this is actually really cool to share. This is, you see, this is a colony, which means they're probably going to be everywhere, hopefully. It's a colony of flagellates. It's called, I think it's called Anthophysa, and it is exactly that, a colony of flagellates. So each one of them has its own little flagellum, and they come together, and they're hard to chase. They're hard to capture because they're up and down and in and out. But they just cruise like that, you know. And these there. See, I told you there's going to be multiples. There they are. See that? So I'm going to try my best to catch one at 400. You've got horizontal gene transfer going on here. If I had to guess, or some type of reproduction. That's right. Let me drop back to 200. So this is another thing about this setup. I'm going to go 400 because I'm looking for septa. That way I can be sure that it looks like there's septa there. It looks like there's septa right there. So I would call this a fungal hyphae, which is developing 2 months. Yeah. So let's just dive in and see how fungal this is. There's a testate amoeba there. There's more flagellates, ciliates. So we've got already tons and tons of activity. There's more fungi there. Look at this. What is happening here? Yeah, at the edge of the slide. A lot of times when you're at the edge of the slide, wow. So flagellate city. Take a look at this. This is what I'm talking about a month and a half in. And we've got a party going on. Imagine the transfer of energy, nutrients, the horizontal gene transferring that's going on here, the communication and exchanges between microbes. Okay, so we're going to back up a little bit. And you see something, I see something moving. Yeah, there you go. What is this? Let's go to 100. Is that a worm or is that a massive nematode? That is a massive nematode. We are at 100 time magnification, and look at the size of this nematode. That is impressive. I might even be able to see that on the glass. Yeah, I'm sure I can if I really wanted to. I don't have a 40 because I changed my gear to put a 6 on it. But that's huge. So we've got nematodes as well. I don't think they discriminate on soils. If there's bacteria in them, nematodes are going to show up to that party. But at this stage, what I'm most after, what I'm most excited about in feeding Look at this. This is a perfect example of how we hear that bacteria glues itself to each other and to organic matter and to other microbes. EPS, extracellular polymeric substances. This is what's happening. We're at 200. Let's go to 400. It's so dense. And then there are ciliates underneath it. And here I'm just going, I guess I'm bringing it up. That's above. I'll go lower. I'll try to get to the bottom. Either way, that is a perfect example of it. You know, you've got all these little holes and pockets where that's a big colony too. This looks like a potential. Well, I don't know what that is. I thought it might have been a spore. Mind you, we just turned this on. We just opened up this. I mean, we just got into this slide. So I'm already about 6 minutes in on this. I can deep dive forever here. I could easily be here for an hour making a video, and I've done it on my YouTube. I had to chill out on that a little bit. And there's, by the way, I'm just pushing through a lot of fungal. So it's already fungal. I'll jump into 200. Maybe we could see a little more. See that there? Hyphae. Hyphae there. Potential there. So I don't know why. I don't know. This is usually the case. It's not uncommon. I'm not looking at anything here that's uncommon. I've been observing this stuff for well over a year. You've got these two microbes just swapping genes and cruising while they do it. So, you know, the idea of these genes being crossed, genetics being crossed, creating who knows what, you know, there's something, there's, you know, these electrogenic microbes, what they do. And let me see, I'll add little images and pop-ups here. But a geobacter, for example, is a bacterium that even creates these little hairs or wires, if you will, and they will plug into another microbe like Clostridium, for example, and they will transfer electrons to Clostridium, and then Clostridium will transfer back its waste, and they will fuel. You know, it's syntrophy, right? They fuel each other. They need each other to operate and power each other up. But all the while, everything they're releasing is you know, one of them is eating metals, one of them is converting. I know the geobacter, for example, will convert toxins. You know, and they're also using it for energy.
So here's an
And I'll
example of a single cell of Shionella onidensis MR1. So this is this white cell right here. And the hair-like things that you see coming out of it, each one of those is an example of a bacterial nanowire. If you're a bacterium like Shionella, you build this wire out of your cell body that goes all the way to the thing that you're breathing, be it a solid surface or the electrode of a microbial fuel cell or something else, and you use that bacterial nanowire to transfer electrons just like we would use a breathing tube in order to breathe oxygen.
and I'll post a couple and this is easy to look up. This is Science Direct and a couple others, Wikipedia, and you can definitely get put on the right direction. I'll show a couple images here. There's a whole lot of action going on that I want to be a part of. You know, these electrogenic microbes are pushing electrons to organic matter, to carbon, charcoal, and I'll share some of that as well. I'm going to try to keep this short because I do have a lot of microscopy I'd like to throw on the table here. So this is the first brute can. This is a month in. I will end up following through the progression of these cans and finalizing a video on YouTube, or even just as I go, I will post these videos. And just email me for that link, and I'll keep you. Maybe I'll create a list for anyone who's interested on the videos and send you those videos as I make them. Take a look at how active this corner of the slide is, and I wanted to share with you that these flagellates, because you've got these colonies of flagellates. And I want to thank David Seymour for sending me these illustrations on these flagellates. He is an author, illustrator, microscopist who has spent a lifetime documenting freshwater protozoa, freshwater microbes, which directly translate to soil. I started with his first book. He ships from Australia, and I was hooked. I literally use this. It sits next to my microscope as a key for identifying microbes. And he's been generous enough to allow me to use his work. His contribution to this space is incredible. And as an artist, his attention to detail, spot on. And his algae work, forget about it. I wanted to share this, what looks like a vorticella. If you just saw that thing bounce there, these usually open up and they're filter feeders, which means they'll start just pulling everything in. But it's not fully expressed itself here. All right, I remember what's going on here. This is called binary fission. I actually have more videos of this. This potential vorticella is splitting in two. It's becoming an exact replica of itself. DNA, nucleus, everything is creating a sister, an exact copy of it. And that's how these reproduce. It's really cool. And I'm gonna maybe stick around and see if I can capture this and then hit a fast forward button on it. Yep. There it is. Man, he just dipped too. It's gone. That's it. That's cool. Just got to witness how binary fission works. That's why we stick around. I'm also going to add to this that depending on how serious you want to get with it, I take these pruners and I prune in my green. I want this one super tight. I also want this one really, really tight because this one is not going to be holding as much water as these. These I'm going to add compost to them, add maybe a couple of my microbial inoculations, but for the most part, these are just going to be loose greens that will break down, and we'll see all these break down together. Show you. This is a bucket of my carbon, my wood chips, some compost, charcoal, and mushroom block. And I'm just going to start now. I just push this all in with a bucket, with a shovel over here. This is what this one's looking like. And I'm just going to start capping it, really, and it's going to work its way down. This is really tough to do with one hand. But you get where I'm going with this. Just topping it. And let it sink. Okay, here's where we're at. It's lunchtime. I'm probably about 2.5 hours in on this thing. And I've got them almost done. These guys appear to be done, but if I were to push that in, there's still room for more organic matter. And I will demonstrate that right now with a fork. See, I just want to get it in more. I want to pack that. Same over here. Oh, is that not going? There you go. And then here, remember, this is the one that's not going to be flooded. So I've been steady feeding this thing water, moisture. Then this is the other one. So I'm going to have quick lunch, let these sit, and then, so this biology here, by the way, my more, call it more expensive microbes, mixture of microbes, I do it at the end, especially on the dry one. I can actually, these ones really wouldn't matter, I guess, but on the dry one I want it at the end so that I water it in and I don't have it run off the bottom of the container. But this is where I'm at now, and we're almost done, and I haven't even touched, I haven't even scratched the surface of all this stuff. So there's going to be more composting. We're always composting, but this video here is going to be specific to what we got going on here. Yeah, so this is going to be topped off again with microgreens because of the protozoas that you get out of this.
Yeah, you get all kinds of stuff.
You get all kinds of protozoas. I've tested this with Rick. Is it the legumes that cause the protozoa?
Peas.
Peas.
Peas. Remember C4s?
C4s. Your C4 grasses are going to get you protozoa. So we're going to dump these on top, cap them off, and let them go.
Ask Matt on that. Matt will tell you.
Sure will.
Microgreen peas.
Microgreen peas.
Microgreen buckwheat.
All right, cool. Let's get through this. This is the suboxic state. This is the party zone. This is where it's all going. Look at this field of view here. You have a worm here that I have not been able to identify. There is a vorticella right there. Another worm there. Ciliate right there. There's fungal hyphae surrounding everything. Nematode, rotifer, microanthropod. What else can I say? What else do you say about something like this? This is we are in one field of view here. You've got probably an actinobacteria. Oh, here, spirulina. And this spirulina goes quick. That is a prebiotic. They enjoy that. That is jam-packed with amino acids. That is jam-packed with the B complex. Imagine what that's doing to your body. Imagine what that's doing to your plant, your soil, your body, your health, your mind. It all just comes together here. This is, I'm not gonna even. I'm gonna wrap this here. Let's keep moving a little bit, but ultimately, I have a couple more things I want to share with you. I know I'm pushing the length of this video. I just, I want to get into the artistic side of things and other things that we do, other ways that we compost, other ways that we introduce biology into our compost to get, to levels like this and beyond. But it is an impressive thing to look at. It's just so much happening. Look at this vorticella. This is the filter feeder again. It's just pulling in microbes and just discarding what it doesn't want. Fantastic shot. You can see just about everything inside. And you got the worm over here on this side, just chowing down, building soil. This is, it almost leaves me speechless. Absolutely speechless. All right, so we've been through the anoxic. We've been through the suboxic. We've been through some of these barrels. Now I'm going to take you to the oxic. I'm going to take you to the aerobic. I'm going to take you to the final product of these Faze Composting brute cans, garbage cans, whatever you want to call them. And I'm going to start pushing through a little bit because, I could probably be here for hours. I do. Now, this is real. I'm not real time, but this is as real time as it's going to get. I did do this for the Our Soil Summit. These videos are not old videos. When I do cutting clips, I'm probably sharing something. I will be sharing microscopy that I've just saved. The art of soil is a thing that I love so much. Another thing that I enjoy doing, it's art's always been a part of my life, and I've been able to transition that with the microscope. I've been able to really just blow that thing up. So here we are at 440 time magnification, and I can already see a nematode here. There's something just zipping around up there. Let's see over here. Look at this huge piece of carbon. Biochar is usually, not usually, biochar is black, same way you know it. And let me get closer. Clean this up. So let's see if we can find that. There's a nematode. Man, look at the amount of spores in this. I mean, come on. The nematode, yeah, beautiful. But look at the spores everywhere. All of this are spores. That's a lot of spores. Let's get back to that. Let me jump back to 100 here. This would have, not sure what that was. This is something I want to share about carbon, by the way. With the epifluorescent lamp, it's another, I use it as a tool for carbon, understanding your inoculation. I mean, look at this. Take a look at that. Look at the amount of spores on that too. So, carbon is we start getting to paramagnetism, which Rick is huge into, and me. I mean, he's obviously, the way carbon works in soil, and it's a neutral. It's got a neutral charge to it, and it can take on electrons. It can take on protons. It's a soil reef. I call it a soil reef. I'm going to share a video with you. This is like some type of organic matter, though. Here, you could see. Let's go a little bit deeper. I'm only at 100. It's maybe it could have been a piece of a root. Maybe it's fluorescing. Maybe that's phosphorus, or who knows? I don't know at this point. I'll just know that it's beneficial, and I want it. I'm at 200. Let me go to 400 and see if we get lucky with a better shot, because epifluorescence at 400 gets a little out of whack. But anyway, I'm going to jump back to 100. I'm going to try to stay focused here. That's a beautiful piece of organic matter. Completely loaded up. Now, mind you, we use mushroom blocks in everything. Just about everything. It is a powerhouse. This here, this microbe, let's take a look at it. I've got tons of pictures of it. So this looks like the Heliopora rosea, which is a purple testate amoeba. That is a beautiful amoeba, and it is a large amoeba, testate amoeba. And I have many, many images of this thing. This is when you know your soil is just happy. Your compost is happy. So let me push through. I know there's going to be a lot more activity around here. I can't get over, though. There's another nematode. And by the way, there are testates everywhere. So look at how cool that looks. Let's dial in on this testate here. Look at that. So this testate amoeba, this is an outer shell. And you know what I've read and I've learned, that inside of this testate amoeba is an encysted amoeba. It has gone into its dormancy to protect itself inside of this test. Really cool. Look at this here. This looks like it might be a spore. I don't know what the word is. Germinating? Oh, no, that could be an amoeba too. I can't tell at this point. This nematode, as you can see how viscous the water is. Look how everything's just kind of moving. This nematode around here is moving everything. So that's, you start getting into the, what is that easy water, fourth phase water. And here's a little a fungal. So there's no question in my mind that this is fungal. Obviously the spores, but let's I'm sure we're going to start bumping into some hyphae here. There's fungal hyphae there. Let me back it up one more, try to clean it up. And sorry, I know I'm in and out, but I got to keep it moving. Otherwise I could be here for 3-4 hours. Look at that. You see here, that right there, that I'm going to guess is a spore. That is no, that is beautiful. That is a testate amoeba that is alive and well, and wow, what a treat. This is cool. So these testate amoebas have these pseudopods, and they reach out. Basically, they reach these fingers and tentacles out, and they grab and move and eat bacteria that way. I have an amazing image. That's one video I will share. It is the nicest I've ever captured in a testate amoeba, and I don't know. Hopefully, hopefully I can outmatch that video. But this is a very small testate amoeba too. I'm at 400 time magnification, and it's using its pseudopods to reach out, and it moves that way. This compost is gonna make soil, wherever it goes, extremely happy, and it's gonna end up turning sand into soil. And then when you consider everything that we've put in here, all the nutrients and minerals and carbon, micronized biochar, liquid clay, that's another thing that we use. Look it up. I was watching an old video of Matt one day. I'm talking probably a 10-year-old video of Matt, and he starts talking about liquid clay. I'm like, what? I do a little research on it, and of course Rick had it, so I was like, cool. Let's start throwing that in the compost. I'm gonna back out. That's a beautiful testate amoeba. I've always enjoyed running into them. Usually you'll find them like this, not really moving. This one's been vacated, it seems. So this is what I'm talking about. I'm already 10 minutes into this video, so I'm gonna go ahead and, a lot of this stuff you'll find on my YouTube channel. I go deeper into these videos, and on some of them I'll go an hour just having a good time, just recording my microscopy. Different type of spores too, with diversity of spores. All right, on to the next one. Well, let's do this real quick. Fungal hyphae. If I need to move in, I know hyphae is an important piece of this, and I tend to just blow through it. I'm used to seeing it, to be honest, and I look at it and just keep moving, but I do recognize when it's not there. There's like a testate there as well. But again, man, the spores here, how could it not be fungal, right? It's just waiting to hit some soil, waiting to I don't know, sporulate, germinate, whatever you want to call it at this point. It just knows when it's time. And I'm sure that if there's another nematode testate, and I'm blowing through biology here. There's testates everywhere. I'm sure that extremely happy with it. I mean, look at this field of view here. 1, 2, 3, 4, 5, potentially 6, potentially 7, 8, 9. About 9 testates in this field of view alone. And there are more spores than there are testates. All right, so now that the phase composting portion is pretty much wrapped up, we can, I feel like I got the work out of the way and I can play for a little bit here. I'm going to try to keep I've been trying to keep this video short. So I'm going to demonstrate a couple little techniques here and there, just things that we do as far as biology. When it comes to creating biology, I've taken Matt's entire action chapters chapter, and I've done it all. And then I've gone and I've done more. As you can see behind me, I grow purple non-sulfur bacteria, I grow spirulina, and I grow chlorella regularly because they are part of everything I do. And that's not including the FPJs, the FPPs, the OPPs, and all that other down with me stuff. So I'm gonna just dive into some of these things here and there, jump in, mix it up a little, have a little diversity even in my video. So enjoy. I've got some nice artwork in microscopy captured, and I want to share it. Let's get into it. And here's something that I absolutely want to share. This is a piece of biochar. This is carbon, this big black carbon. I call this a soil reef. This is this big worm here. This is an Elizoma hempergy. And everything's attracted to this biochar. It seems like, being that it's fully charged and loaded, I was excited to catch this, and this is what these observations I find of microbiology. It's a reef. I don't even know what else to say. And when you put this epifluorescent light on it, it's going to expose all the nutrients and minerals that have been magnetically and paramagnetically and drawn to it, being that carbon has a neutral substance. It can donate, give, and receive electrons and protons, and the biology just loves it. So another fantastic way to verify that your inoculations, your biochar charge is there. And I've done this under composting, and I've done it in buckets filled with microbes, and the results are greater for me in compost. Keep that in mind when you're inoculating your biochar, and try it different ways.
Yeah. Okay, so where do I start with this? This is going to be Bokashi bins that old Rick here taught me about, which is brilliant. This came from having to deal with raccoons, right? Yep. So what do we do now? We're going to Bokashi directly and let the leachate go directly into this compost pile. And what I'm doing is I'm recessing these things about 2 to 3 inches down. And since we're at it, we're going to have a little contest here. 3 versus 3. 3 Terraganic versus... 3 Terraganic Bokashi versus 3 mushroom blocks straight up. Here's the Terraganic stuff. They've got a good Bokashi. You can ask this guy. He supports the cause. He buys them. But let's find out. So we're going to put at the bottom. This is a biochar compost. This started at 100% biochar. Got all that too. I got all those videos. Man. So we're going to put these in the bottom and let that leachate and all those minerals and microbes saturate. And what is that, like filtering it? It's
going to absorb all the minerals.
The Bokashi, the biochar is going to absorb all the minerals.
And biology.
So we end up watering it all in. Yeah, I dig it. Okay, let me get to it. All right, here's where we look at topped off. We'll just keep watering it in. And you can imagine what ends up in here. This is all next level of adding nutrients in biology, minerals, hormones.
And what we are looking at here is this microbe. This round microbe is called a Sectoria. David Seymour helped me identify that microbe, and what it's doing is it's lodged itself into this ciliate, and it is actually sucking the life out of this ciliate. And you can see that it's connected to this piece of organic matter using glues, extracellular polymeric substances. That's why it's spinning. It's see the little hairs, it's trying to take off, and it's not getting anywhere because these glues are anchored to this organic matter and it's holding it back. This went on for quite a while. I was watching this and observed it for maybe about an hour or so before my slides started drying out. These microbes holding on, and look at here how at this point it's the organic matter is not even in the picture anymore. So it's continued to stretch out, and the Sectorias, I'm wondering if that's by design that it's holding on to the using the glue to anchor itself. I wouldn't doubt it. Otherwise, I guess it wouldn't matter. It'd be taking a joyride. I've also captured this behavior or this feeding. It's a feeding. It's what they do. I've captured it while they're just hanging on the back of this thing, and that's pretty much what they do. They take the life out of them, and I've even seen these things recover from it though. So it's pretty wild. I mean, I've captured so much that I don't understand, and we're not going to understand. Look at this rotifer. Look how strong this glue is. It just it's clumsy. It just pushes through. No issues. Just let's go. And it seems like what's become really important to me is teaching this for more than one reason. The obvious, it's important. I absorb it as a layman. I understand it as a layman, and I'm having to work. I feel like I have to work twice as hard to retain. I had to teach myself to learn again, being that I hadn't been learning in such long, and I didn't need to, right? I got my contractor and whatever I did there to get that license, but after that, it was just work. So the interesting part of all of this is that I learn from these kids, and it's really cool. This is my nephew here. I'm going to play this real quick, and it was just a simple little comment that sent me into a rabbit hole.
I wonder how fast they go, like how much miles per hour they go.
Miles per hour, huh?
Yeah, 1 mile per hour or something.
No way.
Do they?
Look it up. Yeah, that's my nephew. That's me teaching my nephew, or is he teaching me? Because I did go to bed that night, and I started wondering why ciliates specifically move a lot faster than aerobic microbes. And some of the research that I've been reading on, and I'm not done with it, is that these ciliates, they will eat bacteria and create 2 ATP. ATP is the final product of energy, our final energy product. When we blink, we move, we're burning ATP. They'll create 2 ATP per 1 sugar molecule once they eat the bacteria. Aerobic microbes will create 37. So these ciliates, they're taking it in sugar rushes, and they're bouncing around everywhere because they have to keep moving. And again, this is just the research that I'm diving into. Go look into it. I'd love to hear more about it myself. So these kids are teaching me. And we're at 100. Wow. All right. Man, that's big. If you go to 40, and by the way, when people normally are doing these soil samples, look at how big that is at 40. That's wild. You probably can see it right on the slide. I bet you see a little white dot somewhere there. In this case, we'll be right in the middle.
Yeah, I see it.
You see it, right?
Yeah, I see it. I see it moving.
Yeah, it's huge.
Yeah.
All right, cool. So we're looking at Jerry, this nematode here. Massive nematode under epilight. We were trying to get him to move. But this is my first class over here at Winter Garden. Say what's up. What's up to the Our Soil Summit. Hi. Getting it done.
It looks like that one.
What do you got? Tell me what you got. Paint marker for what? What do you got in that cup?
To write my name.
Your name on what? What's in there?
The dirt.
Dirt?
And my soil.
What's the difference?
Dirt is dead soil.
That's right. We're going to take that away for this year. What's the difference between dirt and soil?
Soil has life.
There you go. Dirt is dead soil. You guys did awesome today. All right, so this is where things can get really interesting. this is something I made. I was trying to make mycorrhizal fungi. This was before I started Matt's classes. I was already all in. It just received my microscope, and I was trying to create mycorrhizal fungi, which I know now cannot happen. But what I ended up making, and luckily I wrote down my ingredients, is this. And this is, as you can see, just nematode after nematode after nematode. And it's something, the only thing I could tell you for certain, it's called Endotokia matricida. Endo, inside. The Tokia part, if I remember right, has to do with the birthing, and matricida is the death of mother. And what's happening is that there is a bacterium that is infecting the nematode. I've also read that it's symbiotic. So again, I've been looking at this for a while. I've had a couple people looking at it with me, but what it does is that it infects the mother and causes the eggs to stay trapped inside of the mother. And the mother births the babies inside, and they eat. She dies. She gets about 10 times larger than she normally would, or even greater. It's not much research that I've been able to find. I mean, and here's a spectacular shot of it. As you can see, the nematodes inside, the mother's already dead, and they'll just keep reproducing in this system. These are bacterial feeders, by the way. So I've put this in garden beds. I've put it in controlled compost piles, and it seems that the minute they hit that compost, this stops. And I've read that it's a symbiotic relationship. I've read that this happens in an effort to keep the species going and alive. I've read that the bacterium is just there and stressing the mother out, causing these stress hormones to trigger. And so I don't know for certain. Maybe we just don't know for certain, but I will be putting a full video out on. I mean, I'm going to consolidate all my notes, put out what I know. At the end of the day, I don't know anything. I always say that. I can only read, and one thing says one thing, and then the other says the other. But all the same, every time I make this recipe, this happens. And it's not only this that happens. This is happening to almost everything in this system. I mean, everything is so Jurassic in this system. And again, I will be sharing that video. When I say Jurassic, I mean water bears are larger, their eggs are larger, paramecium are larger. So that is just an amazing shot, though. Endotokia matrecida. All right, so as promised, here's this video of this outstanding shot of this test-state amoeba. I mean, take a look at this thing. And then, it's complemented by the fungi, the hyphae. It is, they make their own shells, which is just even more impressive to me, that they would gather things from the soil and from the environment. They'll even make shells out of diatoms and silica and whatever it is they can grab onto, carbon. But this is the cleanest shot I've been able to capture under light microscopy. And there are other microscopes that'll get you some excellent shots, but this one here is just cruising along, and it's gonna find its way around that hyphae and then just kind of dive down into that organic matter. Just blows me away. It really does. creating life. So that they create life, they cycle nutrients, and we're lucky to have them. That's Cotamuk Via would say, I honor them. All right, with that, I'm gonna wrap it up. But I would like to say, if you're ever in Southwest Florida, come check us out. Come check me out. You'll find me at Rampart Farmstead in Punta Gorda, Florida, place where I've teamed up with a family that has a nursery there that is going regenerative teaching, regenerative education. So I do want to say that I'm grateful, and had not for this community being as generous as it is, I would not be where I'm at today. I mean, the knowledge is being handed to us right now, and we need to keep it that way. It's very important that we do that. Very important that we document. I'm all in on that. I can't wait for the database to go live. I will definitely be knocking on that door. It was about a year ago to date. This place got hit with a devastating hurricane, and man, we were underwater, under ocean water here, salts. We beat it with chemistry. We beat it with bio. I'm going to finish this video with a walkthrough of these banana patches. You can't even tell we got hit with hurricanes, and that's the power of the microbe. The microbe is going to sort it out. I'm a true believer of microbes and what they're capable of and what we don't even know they're capable of. I will not stop learning. I will not stop teaching. I am only beginning my journey, and I definitely again want to thank Matt for having me on, brother. When you asked me to be on, you blew me away. I'm honored. And if anybody in this community needs any questions or anything I can possibly help with, don't hesitate to reach out. You'll find me on any social media platform under I Grow Soil, IGROSOIL. Get to it, man. Grow your microbes, grow your soil, grow obsessively. I Grow Soil, and I'm out.